this video, we are going to find the specific heat of a sample, the molar specific heat of a sample, and the number of moles in a sample. So the question is, a certain substance has mass per mole of 50 grams per mole. When 314 joules, that is the energy, is added as heat to the sample of mass 30 grams, and the sample's temperature rises from 25 degrees to 45 degrees Celsius. Okay, so find A, the specific heat capacity of the sample, B, what is the molar specific heat of the sample, and C, how many moles are in the sample. So this is how we are going to proceed. So in order for us to find, or rather to work out a certain problem well, we need to come up with the data. So we first collect the data. So data, we have been given mass per mole, which is 50 grams per mole. Then the other thing is energy, which is heat energy. (314 joules), T1, which is the temperature one. Our T2 is 45. Now we are told to find the specific heat capacity. Specific heat capacity. So let me just erase the first part. We know that heat energy is given by where this is the heat energy and this is the mass, and this is the specific heat capacity, and this is the change in temperature. Change in temperature. So we can now proceed as follows. Make specific heat capacity of a sample the subject of the formula. We are going to have and plugging in the values, we are going to have 314 joules over the mass, which is 30 grams, and the change in temperature, that is 45 minus 20 minus 25, we are going to get 20 degrees Celsius. And what we are going to get is and the value that we're going to get is so this is the specific heat capacity of a sample after plugging in the value. And the second, or rather the other question that follows, is asking us to find the molar specific heat capacity. The molar specific heat capacity. So that one, it is simply the same. So yeah, so C molar. What we're going to have is Q over N dt. So this is the formula for finding the molar specific heat capacity, where N is equal to the number of moles, which is given by number of moles, which is N is equal to mass over molar mass. So the mass given there is 30 over the molar mass, which is 50 grams per mole. So gram and gram will cancel, and this will cancel. So what we're going to have here is 0.6 moles. So our Cm will be 214 divided by 0.6 mole times the change in temperature, which is simply 20 degrees Celsius. This is going to give us 26.5 25 joules per more degrees Celsius. So this is the specific, the molar specific heat for the sample. And finally, the number of moles, of which we are just from finding, which is just that one, where, so this is C, the number of moles is equal to mass over molar mass, which is 30 over per mole. Our N is going to be, this and this will cancel, this and this will cancel. And what we're going to have is 0.6. So this is the value for the number of moles. Thank you so much for watching the video.